Hey everyone, in this video we are going to be looking at the big ideas for section 6.6. And so we've been learning about geometric probability, but how can we check to see if we have a geometric setting? Well, for binomials, we were looking at the acronym BINS, B-I-N-S. But for geometry, we are looking at BIFS, B-I-F-S. So three of these are the same as what we were looking at for binomial, but one of them is different for geometric. The first one is binary outcomes. In other words, binary means two, so there are exactly two outcomes, and we call those outcomes a success and a failure. The I stands for independent, and in particular, independent trials. So each trial is independent of all the other trials. I'm going to skip to the S, and the reason why is because it goes along with independent trials. If the trials are independent, then S stands for success. The probability of a success is the same for each one of the trials. So these three things that we need to check are the same as binomial probabilities, but this one, this F, is different. And that is F, count until the first success. So for geometric, there are binary outcomes, a success and a failure. Each trial is independent of the other trials. We go or count until we get to the first success, and the probability of a success is the same for each trial. Now, what about the geometric formula? So if we're looking at the formula for a geometric probability, it looks like this. Now, you could use little x instead of k here if you wanted to, but they mean the same thing. So the probability of x being equal to a particular value is equal to p, the probability of a success, times 1 minus p, which is the probability of a failure, raised to the k minus 1 power. So you should be able to use this formula in order to find a geometric probability. Finally, we look at describing a geometric formula. So when we look at this one, whenever we describe a distribution, that shouldn't say formula, that should say a geometric distribution. Sorry about that. But whenever we look at describing a distribution, we should be thinking SOX. So shape, center, and spread or variability. So let's take a look at all of these. The shape of a geometric distribution is always going to be skewed right. So the shape of a geometric distribution, skewed right. The center of a geometric distribution can be described by its mean or expected value, and this is the formula for the mean or expected value of a geometric probability distribution, 1 over the probability of a success. And then finally, the variability. How do we describe the variability? Well, we describe it with the standard deviation of a geometric distribution. And the formula to find the standard deviation of a geometric distribution is given with the square root of 1 minus p divided by p. So we should be able to describe the shape, center, and variability for a geometric distribution using these formulas and knowing that the shape is skewed right. That's all we've got for the big ideas for section 6.6. Hopefully this helps you, and hopefully you have a great day.